Today we are going to study Science and Technology Part 1st. Chapter 2, Periodic Classification of Elements. Friends, in the last standard we had studied that the atom of an element is of only one type. This year we are going to see the types and classification of elements. You might know at present around 118 elements are known to the scientific world. But this was in the situation around year 1800. At that time, only 30 elements were known. More and more elements were discovered with time. Various properties of elements were known. Initially, elements were classified as metals and non-metals only. Then later on, metalloids were discovered. So scientists were looking for a classification that would give, or rather help us to get a better understanding of elements. So in the year 1817, a German scientist, Dobereiner, suggested a method. He suggested that the properties of the elements are related to their atomic mass. So, he made a group of 3 elements showing same chemical properties. He called his group of 3 elements a triad. This triad was such that the average of atomic mass of the extreme elements was approximately equal to the atomic mass of the middle element. When we take a look at the first example in the table given here, we see that lithium, sodium and potassium. Atomic mass of lithium is 6.9 while that of potassium is 39.1. When we take the average of the atomic masses of the both, we get the average equal to 23, which is exactly the atomic mass of sodium. Similarly, the other 2 examples show that the average of the extremes is equal or approximately equal to the atomic mass of the middle element, such as calcium, strontium, barium, and chlorine, bromine and iodine. But this wasn't the case for all elements. Dobereiner wasn't able to classify all the elements in the form of triads, which led to the failure of the Dobereiner's triads. Later, in the year 1866, an English scientist, John Newland, correlated the atomic mass and the properties of the elements by various methods. He arranged the elements in the increasing order of their atomic masses. He found that after every 8th element, the properties were repeated. That is, the property of the 8th element was similar to that of the first. He arranged these elements according to the musical note Do, Re, Mi, Fa, Sol, La, Ti, which was similar to the Indian musical note Sa, Re, Ga, Ma, Pa, Dha, Ni, Sa. Starting with lightest element hydrogen and ended with thorium. The similarity that was observed between 8th and 1st element was called as laws of octaves by Newland. But many limitations were there in Newland's octave. It was found that this law was applicable only up till calcium. Later on, every 8th element wasn't following the property similar to that of the first. At the time of Newland, about 56 elements were known. So in order to accommodate all the elements in the boxes, he placed two orders in the same position, such as cobalt and nickel, and cerium and lanthanum. Moreover, he also placed the elements of different properties in octaves, like cobalt and nickel were placed with halogens under the note Do, while iron having similar property with cobalt and nickel was placed away along with non-metals like oxygen and sulfur under the note T. Also, the newly discovered elements wasn't able to be accommodated in the Newland's octave. Their properties were discovered and they weren't the fit for the Newland's octave, which led to the failure of the octaves. Later on, the Russian scientist Mendeleev put forth the important step of classification of element during period 1869 to 1872. Mendeleev considered atomic mass as the fundamental property for the classification of elements. During his time, about 63 elements were known. He arranged these elements in the increasing of their atomic masses. He transformed the periodic table of the elements according to the physical and chemical properties of those elements. Mendeleev's periodic table was based on the properties like molecular formula, melting point, boiling point, and densities of the elements. Also, their hydrides and oxides were taken into consideration. Mendeleev's periodic law stated that the properties of the elements are periodic function of their atomic masses. The vertical columns in Mendeleev's periodic table were called as groups, while the horizontal rows were called as periods. Here is the short introduction to the scientist Mendeleev. He was a professor in St. Petersburg University. He made separate card for every known element showing its atomic mass. He arranged the cards in accordance with their atomic masses and properties of the elements, which resulted in the invention of the periodic table of the elements. Now we are going to look at the merits of the Mendeleev's periodic table. Mendeleev revised the atomic masses of some elements and placed these elements according to their properties. For example, previously the atomic mass of beryllium was 14.09 and was changed to correct value of 9.4. Thus, the beryllium was placed before boron. Mendeleev placed few vacant spaces for the elements that were yet to be discovered. He also gave those unknown elements names like Eka boron, Eka aluminium and Eka silicon. He also predicted the properties of these elements which were yet to be discovered. As the table 2.4 gives the actual and predicted properties by the Mendeleev for the element gallium, which were found to be similar. The other merit of Mendeleev's periodic table was that during the time of Mendeleev, noble gases weren't discovered. So there wasn't a place for the noble gases. But Mendeleev had already created zero group for those gases. And later on, the noble gases were placed in the periodic table very well without disturbing the placement of other elements. Demerits of Mendeleevs periodic table. As there were merits of Mendeleev's periodic table, there were also few demerits which led to the failure of his periodic table. The atomic mass of cobalt and nickel is approximately same. So there were ambiguity or rather confusion about the placement of these elements in the periodic table. Later on, isotopes were discovered. The isotopes had the same chemical properties but different atomic masses. So it was the biggest challenge for the placement of the isotopes in the Mendeleev's periodic table. Since the elements were arranged in the increasing order of their atomic masses, the arrangement wasn't uniform, as it was unable to predict how many more elements were yet to be discovered between the two elements. Also, there was contradiction on the position of hydrogen, as the hydrogen showed properties similar to halogens as well as to alkali metals, so it was not easy to give a particular position to hydrogen. Table 2.5 and 2.6 shows the chemical properties of hydrogen following alkali metals and halogen respectively. Here are two questions in your textbook. Try to recall the Mendeleev's periodic table and answer these questions. Practice questions are given here. Understand the chapter and write these answers. Also, try to answer the questions given in between the chapter. If you have any doubt regarding this chapter, do ask in the comment section below. Do subscribe my channel and press the bell icon for notification. Do like and share the video. Thank you.